So let's talk about negative integer exponents. And once you get the hang of this, this is pretty easy. So let's look at 5 to the negative 1 times 5 to the 1. Okay, based on what we said last time, since these two bases are the same, what happens with those exponents when you multiply these two things that have the same base? What do you do with the exponents? Yeah, you add them up, which in this case means you're adding negative 1 plus 1, which means you end up with 5 to the 0. Okay, what did we say last time? Anything that's not 0 raised to the 0 power will equal, okay, good, 1. So what that says is, whatever 5 to the negative 1 is, and that's the question mark here, is what does that even mean, 5 to the negative 1? But what we have up here says that 5 to the negative 1 times 5 to the 1 has to be 1 if this definition of, let's say, negative exponents is going to be consistent with the exponent properties that we developed last time. And we are trying to build a set of rules here that works for all exponents, not just positive ones, but negative ones too. Alright, so think about what that says. 5 to the negative 1 times 5 to the 1 equals 1. And of course I know 5 to the 1 is just 5. So question, what's the only number that you can multiply by 5 and get 1? Well, think about that. This can't be 1, can it? Okay, if it's 0, what's 0 times 5? That's still 0? That's a good one, Wes. You are correct. Okay, Kara says it has to be a fraction. Does everybody see that? I agree with that statement. What fraction? So if I had a mystery number times 5 and the answer was 1, how would you figure out what that mystery number is? Couldn't you just treat that as an equation where you're solving for that unknown x value? What would that unknown x value be? Okay, Kara says 1/5. That does make sense, doesn't it? If you take 1/5 of 5, you're definitely going to get 1. Everybody agree with that? Okay, now, if this has to be true, and we know this is true, then what does that say about 5 to the negative 1? It has to be equal to 1/5. With me so far? Here, let's try another one. What's 5 to the negative 2 times 5 squared? Well, that should be 5 to the negative 2 plus 2, which would be 5 to the 0, which should be 1. So we're saying 5 to the negative 2 times 5 squared is 1. What's 5 squared? It's 25. Okay, question. If that's true, what does 5 to the negative 2 have to mean? What's the number that you multiply times 25 and get 1? Okay, not 1/10, but you're thinking the right way. Not quite. What would you multiply times 25 and get 1? Is it 1/4 or would it be 1/25? Because if I put a 1/4 here, what's 1/4 times 25th? It's like 6 1/4. But let's put it this way. How do you get a 1 out of a 25? Don't you have to divide 25 by itself? So when up here I asked you, what do you multiply times 5 to get 1? You said 1/5. Okay, what we're saying down here is, what would you multiply by 25 to get 1? Would it be 1/25? I guess the thing we're dancing around here with is, if I give you a number A and I say, what would you multiply that by to get 1? Wouldn't the answer always be the reciprocal of that number? You agree with that? So for example, when I say, what do you multiply by 5 to get 1? It'd be 1/5. What do you multiply by 25 to get 1? 1/25. And in this case, we're saying this guy, when you multiply it by 25, should give you 1. That means this 5 to the negative 2 has to mean 1/25. Alright, now let's summarize what we've got so far here. 5 to the negative 1 we're saying is 1/5. 5 to the negative 2 we're saying is 1/25. Okay, let me give you one more. If I multiplied those two, I would get 1 again, right? And I know 5 cubed is 125. So this would be 5 to the negative 3 times 125 equals 1. If you divided both sides of that equation by 125, then what's 5 to the negative 3? It's 1/125. Okay, do you all see the pattern in looking at these powers of -1, -2, and -3? It looks like 5 to the negative 1 is 1/5 to the 1. Do you see that 5 to the negative 2 is 1/25, which is 1/5 squared? And you should see that 5 to the negative 3, so what ain't negative is equal to the negative over 1. I'll accept that, yeah. This one's definitely 1/5 cubed, so that sounds right. So, let me ask you, what's 3 to the negative 2? It's 1/3 to the positive 2, which is 1/9. Yes. That makes sense so far? If you did learn this in high school, there's a particular way your teacher might have said it, and it might help you remember this. So this 3 to the negative 2 right here, if I just pretend that that was over 1 to make a fraction out of this, doesn't it look like basically what you did is you moved this to the bottom of the fraction so that it ended up down here. And when you did that, what happened to the sign of the exponent? It switched. So some teachers will say something like, when you have something raised to a negative exponent in the numerator of that fraction, move it to the bottom, move that entire factor with that negative exponent to the bottom, and when you move it across the fraction bar, the sign of the exponent switches. Now if you do that, of course, what's left in the top is just 1. Now, just to make sure you see why that's true, if you have 3 to the negative 2 over 1, and you multiply the top and the bottom by 3 squared, the bottom's definitely going to be 3 squared, isn't it? Because it's just 1 times 3 squared. Okay, what do you get when you multiply these two in the top? And since I'm multiplying fractions, I'm just multiplying straight across the top, straight across the bottom. Well, since you're multiplying two things that have the same base, wouldn't you just add the exponents? And if you add those exponents, you get 3 to the 0. What's anything to the 0 power? Which means my answer is 1 over 3 squared. And so you see what happened there. Basically, the effect of this was that I moved that 3 to the negative 2 to the bottom, and when I did, the sign on that exponent switched from a negative to a positive. Notice that that's also true if you start with a negative exponent in the bottom. What is 1 over 3 to the negative 2? It's the same thing as what if you moved him to the top? Right? Because if what we're saying is when you have a negative exponent at the top, you can just move it across the fraction bar at the bottom, and when you do, the sign of the exponent switches. It's also true when you move something with a negative exponent from the bottom of the fraction to the top of the fraction. The sign of the exponent still switches, except now there's nothing in the bottom except a 1, and you have a 3 to a positive 2 sitting in the top of the fraction. Well, that's just 9. And notice, again, what did we say negative or 3 to the negative 2 is? We said it's 1/9. That means 1 over 3 to the negative 2 is 1 over 1/9. Well, what have we always said? When you take 1 and divide it by a fraction, it's the same thing as multiplying by the reciprocal of that fraction, which means I would get 9. So that means our answer up here is correct. And that means really, again, what you're doing when you have a negative exponent, whether it starts out on the top or the bottom, is you're going to move it to the other side, opposite side of the fraction bar, and switch the exponent to a positive. So far, so good? Okay, so let's write a rule here. If I have something to a negative power, our rule now is that's the same thing as 1 over a to the positive number n. And that's our working rule for how to deal with negative exponents. So from here on out, when I see something like 5 to the negative 4, I want to immediately think of that as 1 over 5 to the positive 4. By the same token, if I had something like 1 over a to the negative n, I want to think of that as a to the n. So that means if I have 1 over, let's say, 4 to the negative 2, that should be the same as 4 to the positive 2. Okay, now right along with this, let's combine both of these things at once. So by that I mean, what happens when I have a top and a bottom that is a fraction, and I'm raising it to a negative power? Well, let's see. One thing is for sure, based on our exponent rules from the other day, would that be true? Remember our rule from the other day that said if we have a fraction raised to a power, it means I should be able to raise that power to both the top and the bottom of that fraction individually?
Yes, you just apply it to both places, correct?
Yep. Now, if that's the case, think about what we just said a minute ago. We said if we have something in the top raised to a negative power, I can move that to the bottom, right? Well, if I move him to the bottom, he's 3 squared.
You got to make it a positive.
Yep.
Okay, I see.
And can I do the same thing with this guy, only move him to the top?
So you're just going to swap places with them.
That's it. And do you notice that's the same thing as 5/3 squared? And that's basically just using this rule in reverse. That is, this guy looks like this, and this one is just putting the 5 and the 3 back together and raising the whole thing to the second power. So I think what we just showed there is 3/5 to the negative 2 is the same thing as 5/3 to the 2. So do you see what the rule is there? If I have a over b to the negative n, that's the same thing as what?
B over A to the positive end.
Yep. So this is a combination of the two things that we were doing up here, where I actually have a top and the bottom and a fraction at the same time. And basically what we're saying is that negative in that exponent right there, what is that negative doing? It's flipping the fraction. And that makes sense because we know a negative exponent is telling you to take the factor on one side of the fraction bar and send it to the other side. And that's exactly what that negative does. It sends the 3 to the bottom and the 5 to the top. The square is still there, so I'm still going to have to square this when I get done. Yeah, that is the goal. So Wes just said, is what we're trying to do generally get rid of negatives? And the answer is yes. Ultimately, down the road, not in this class, but more in the next class, you're eventually going to end up doing things like solving equations that contain things with negative powers. Really, to be able to do that, you need to get these powers into positive powers. And this is the way to do it, this flipping back and forth that we're doing. So let's see, here's the rules we need to sort of pay attention to. That one, and now this one that tells us how it works if we have an actual fraction with a top and a bottom. Okay, so what would happen if I had something like x cubed over x to the 7th? And Kara asked something like this at the end of class last time. What did we say the other day when you have something to a power over that same something to another power? When you're dividing things that have the same base, what do you do with the powers?
Subtract.
Yep. Okay, so in this case, what happens when you subtract the bottom exponent from the top exponent?
You'll come up with a negative.
Yep. Okay, now, if this was a problem in your homework and you wrote this is the answer, it won't take it because at the very top of your homework it's going to say write all answers in terms of non-negative exponents, which is what Wes was just talking about. I don't want to leave the answer this way because of the negative exponent. But this is exactly the same thing as what? 1 over x to the positive 4. Because if I just imagine moving that x to the negative 4 down to the bottom of the fraction, moving it across the fraction bar will switch the sign of the exponent. This is the answer. Similarly, if I had, let's say, x to the negative 8 times x to the 5, what would that be if you just multiplied those together? Yep, Kara says x to the negative 3, because we know that when you multiply two things with the same base, you add the powers. Okay, what's the actual answer I want to write? Yep, just flip that thing to the bottom and switch that negative 3 to a positive 3. So far, so good? Yeah, it is. You'll get the hang of it pretty quickly. Alright, I've got a few here for us to work on. So let's look at this first one here. It says 2 to the negative 3 minus 2 to the negative 1. Here, let me make that a little bit bigger. Okay, first of all, what is 2 to the negative 3? It's 1 over 2 to the positive 3, which is actually just 1 over okay, 1 over 8. What's this other one? What's that 2 to the negative 1? Okay, now, just to make sure everybody sees this, Kara just wrote negative 1 half. Everybody does see it's negative 1 half because of this negative, right? It's not because of the negative in the exponent. And this probably deserves a little bit of an extra statement here. Make sure you write this in your notes. Negative powers do not make the expression negative. What I mean by that is when we said 5 to the negative 1 was 1/5, you do notice the negative 1 exponent here. Oops. The negative 1 exponent had nothing to do with making this answer negative. That's probably the most important reminder here about what this is not saying. Negative exponents do not make negative numbers. Negative exponents are basically doing reciprocals. So 5 to the negative 1 means reciprocal of 5, which is 1/5. It definitely doesn't mean negative 5 or negative 1/5 or negative anything. Now, just to be clear here, if there was, no, but it does end up actually being negative 1/2 because there was a negative in the problem. But I'm glad you said that because this is a pretty common mistake, thinking that that negative exponent has something to do with the sign of the answer. Now notice if I had negative 5 to the negative 1, does everybody agree that would be negative 1/5? Because this part says take the reciprocal of 5, which is 1/5, and then this negative is here just because there was a negative to begin with. Everybody see that? Let me ask you this one. What's that one?
Negative 1 over 25.
Yes. Now let me ask you another one. What's that one?
Guess I better let somebody else take that one.
Well, while you're thinking about it, let's look at this one above here. Do you see that that negative 2 simply turned this 5 into 1 over 5 squared, right? And did this power affect this sign at all?
No.
No. Remember our old rule. If you have two things next to each other, like a negative and a 5, and then a power, what's the only thing that that power applies to? It's the thing that immediately precedes it, which is
Yeah.
just the 5, which means the negative is not touched by that power, which is why you got an answer of negative 1/25.
But
Okay,
it's in parentheses, so now it's affecting the whole thing,
yes,
the whole lot. So would it just be positive 1 over 25 then?
yes, because, like you said, what is it I'm flipping to the bottom now? It's not just the 5, it's the entire negative
Negative
5.
5. Yeah.
And like David just said, it's definitely because of these parentheses. So watch out for this. That's something you could easily get caught on, just like we were getting caught on it back when we first dealt with negatives and powers. Okay, now back to this one. It is definitely 1/8 minus 1/2. In other words, isn't this negative exponent expression really just a fraction subtraction, just written in a weird way? That's all it is. And of course, what is this? It's 1/8 minus 4/8, which is minus 3/8. Here, if you guys will give me just a second, let me. Why is that running so hot? That's not good.
Is your computer cooking?
It is. That's the first time it's done that. And no, it's not because it's warmer today. Yeah, nothing weird running. Hmm. Sorry, just give me a second. Hmm. let's do a few of these, and then I'm going to, well, we're already 8 after anyway. Let's do a few of these examples, and then before Monday I probably better try and figure out why this thing's running this way. I did do one update this morning, and I hope that doesn't have anything to do with it. Yeah, it's just dust. Okay, let's do a couple more. Okay, so this next one is what? 9x to the 5th over 2 to the negative 2x to the 8th. And it says simplify this. So let's do the easy part first. Since I'm dividing those two, and those both have the same base, I should just be able to combine those by subtracting exponents, right? Now, when you have x to the 5th divided by x to the 8th, how have we been looking at that? We've said if you're doing division, what do you do with the powers?
You subtract them.
Yep. Which is in this case means x to the 5 minus 8, which would be x to
Negative
the
3.
minus 3,
Yeah.
which is really going to put an x cubed in the bottom, right?
Okay.
Now let's look at that two other ways here on this page just to make sure that makes sense. This is definitely, if I wrote it out in long form, and I know we've looked at this way once before, this is definitely a situation where I can cancel corresponding factors, right? And when you do that, what's left in the bottom? 3x's,
Right.
basically because you were bottom heavy to begin with x's.
Mm-hmm.
Okay, so here's another way you can visualize this just in terms of cancellations. Now I'm going to show you one more way, which is, it's the way I actually do problems like this. When I see x to the 5th over x to the 8th, rather than do the subtraction like we did up here at the top, what I do is mentally figure out which one of these exponents is smaller. Well, it's definitely the one in the top, right? And so what would happen if I moved just that one to the bottom? It would change to x to the minus 5. Agreed? So I'm just picking which one of these two had the smaller power. It's the one in the top. I'm moving that one to the bottom, and when I do, the x to the 5 changes to an x to the negative 5. Okay, now, in the bottom, isn't this now a multiplication? And if it's a multiplication, what do you do with those two powers?
You would add them.
Yep. And if you add 8 minus 5, you get positive 3, don't you?
Yes.
Okay, so do you see the difference in the approach here versus here? In the
Yeah.
top one, I'm doing the subtraction of the top exponent minus the bottom exponent, but if the top exponent's smaller, I'm going to end up with a negative exponent. Well, that just means I need to move it downstairs to change it to a positive exponent. Here, I'm doing the same thing, but sort of in a different way. I am moving the one that has the smaller exponent to the bottom so that it becomes negative. Well, if I do that, this number will be larger, this 5 will be smaller, but it'll have a negative in front of it. When I add those two, I'm guaranteed to get a positive exponent.
Okay. I see what you're saying.
So, which one of these two ways you prefer to look at it is up to you. Um, my own preference is this way. It makes more sense to me, at least it has over the years. So for me, if I see something like x to the 7th over x, let's say x to the 15th, I'm automatically thinking 1 over x to the 15, x to the negative 7, which is 1 over x to the 8. You might want to think of it as x to the 7 minus 15, which is x to the minus 8, but that's the same thing as 1 over x to the 8 when you flip that x to the negative 8 to the bottom. Either way, you're going to get the same thing. So if we go back to this one, I think what we said is you would end up with 3 x's in the bottom. Okay, question, what would you have to do with that 2 to the negative 2? What do you pretty much want to do anytime you see a negative exponent on something? Move it to the top. Okay, if I move it to the top, do you agree the only thing left on the bottom will be that x cubed? And now that 2 squared, that is where you've changed this negative 2 to a positive 2, is now in the top. Okay, what do you have in the top now? You've got 9 times 4. You've got 36. Make sense?
You would just move it to the top, like Carrie had said there. I
Yep.
see what you're saying. I remember back. You just move it to the top, change your negative to a positive.
And then you see, once it's a positive exponent, then we know what to do with it. I know 2 squared is just 4, and that's
Right.
something I can relate to better than I can 2 to the negative 2.
So at that point, you would just work out your number and your exponent, whatever that would be, and
Yep.
then multiply it by the front number.
Yep.
Good deal.
Here, let's try another one. Okay, so this one here, it says negative 5x squared y to the negative 2, all to the negative 2. So negative 5x squared y to the negative 2, all to the negative 2. Okay, what was our rule the other day? The one that David just mentioned a little while ago. If you have things multiplied together and then raised to a power, can't you just apply that power to each of the things inside, as long as those things are all multiplied? And that's a couple of multiplications in there. So what should I do with this negative 2 power? I should apply it to all 3 things inside the parentheses. And would that look like this? So what I'm doing there is raising this guy to the negative 2, and this one to the negative 2, and also this one to the negative 2, which is exactly what this rule says. It says raise this to your power, and then raise this also to your power. It's just that in my problem I have 3 things instead of 2 things. Is that okay so far? So x would just be 1. So you mean, are you talking about this part, Wes? Okay. What happens when you have something to a power raised to another power, which is what that part in yellow looks like? What was the rule the other day for that one? I guess the question is, Okay, so Wes says add. So let me come down here. Okay, this one right here, this one I wrote at the very bottom. How many 2's do you have there? If you take 2 squared times 2 cubed, that's definitely 5, right? Because that one says if you have something to a power and you have that same something to another power and you're multiplying them, you should add the exponents because you're just counting up how many of those you had in total. Okay, but when you do this one, this is 2 squared times itself, or there are 3 of them, right? And that last one should also be a 2. How many 2's overall do you have there? Yeah, definitely 6. Okay, so what happens when you're multiplying two things that have the same base? You add the exponents, which is how we got this 2 plus 3 is 5. What happens when you're multiplying, or rather raising something to a power and then to another power? Yes, that's the multiply. Which means up here, this part in yellow would be x to the good. Okay, now, do you see that after a while this could get pretty fast? If you look at the original problem, when you see this x squared raised to the negative 2, aren't you really just going to multiply those two exponents? That is, you're going to multiply the 2 and the negative 2, and you're going to get x to the negative 4. When you see this negative 2 on the y, and you see that that's being squared, what's that going to give you? Y to the positive 4, because you're just doing negative 2 times negative 2. Now let's be careful on this first one, the one with the negative 5 to the negative 2. And this is like the one David said something about earlier. When you have something in parentheses raised to a negative 2, we know the way to get rid of that negative exponent is to flip the whole thing, right? But since the power applies to a parenthesis set, you have to flip everything inside the parentheses. So what is negative 5 parentheses to the negative 2? It's 1 over negative 5 parentheses to the positive 2. So right there's the sign switch in the exponents. Notice I have not changed the negative 5 at all. It's still there. The only thing I did is flip it to the bottom and change the sign on the exponent, which means you get what? 1 over 25. Okay, if I just sort of picture those guys being over 1, I think what we've got here is x to the negative 4, y to the 4 over 25. What would you want to do to finish simplifying this? Because there's one last part I don't want to leave the way it is. I don't have a problem with the 25.
Be your exponents.
Yeah. Now this one's okay, right?
Yes.
So I can leave that right where it is. But I would want to move the x. Yep. And so when I move him to the bottom, he's just going to become x to the positive 4. And that is my answer.
So, so basically, what you're saying here is you just put the x -4 up from top to bottom
Yep.
just to get rid of it. You just moved it because you wanted to get rid of the
That's it.
negative.
That's it.
Wow.
Now, one last thing here, because we're kind of out of time, and we can always do a few more of these Monday. I will put the homework up for this afternoon. Be careful of one thing, and so I'll make this the last thing we say, just so it's ringing in your ears. So if there's a negative, Kara says, if there's a negative exponent, we'll have a fraction of some sort in the problem. Yes, definitely. Um, unless the negative exponent was in the beginning to start with, then you would be moving it to the top. So what Kara's saying is, if I had a negative exponent in the top to begin with, let's say like that, then for sure I'm going to end up with a fraction, because I'm going to have to move that to the bottom, which will create the fraction. But what if you had a fraction to start with a negative exponent in the bottom? Well, you'd have to move that negative exponent expression to the top, which means now there is just a 1 in the bottom, and really you don't have a fraction anymore. But yes, you're right in thinking that negative exponents in denominators or in numerators are going to create denominators when I flip them to the bottom. Now, notice something here. When I say, x squared y to the negative 3 is x squared over y cubed, because we're doing this move the y to the negative 3 to the bottom of the fraction and switch the sign of the exponent routine. Notice that this works if these two things that are connected are factors. That is, I can only move factors up and down by changing signs on exponents. This does not work with terms. So what I mean by that is, if I had x squared plus y to the negative 3 over, let's say, 5, I can't move this guy to the bottom. Okay, why? Because the thing connecting the x squared and the y to the negative 3 is not a multiplication. It's an addition. Does everybody see the difference between these two? In the first example, the thing that joins the two expressions, the x squared and the y to the negative 3, is a times, which means both of these things are factors. That is, x squared and y to the negative 3 are both factors if that multiplication is between them. Now these two, x squared and y to the negative 3 down here, are not factors because the thing joining them is an addition. Okay, I can't move things up and down in a fraction bar by changing their exponents if they're not factors. In fact, what are these guys here? Aren't they terms? Things that are added and subtracted together that are terms instead of factors? Terms cannot be moved up and down this way by moving or changing the sign of the exponent. I mean, think about it. If I have 2 cubed plus, let's say, 2 to the negative 3 over 5, think about what that is. Kara says, so if there's a negative exponent, we'll have a fraction. That makes sense. Yeah, and for one like this, if I ask you, is this simplified? Well, for right now, what's the only thing you could do with this? You could write this. Does everybody agree with that one? I can't move this guy to the bottom of the big fraction because it's not a factor, it's a term. But on its own, can I change that y to the negative 3 to 1 over y cubed? I know y to the negative 3 is supposed to mean 1 over y cubed, then even though I can't move this y to the negative 3 to the bottom of the big fraction, I can at least rewrite that y to the negative 3 as something that does not involve negative exponents. So at this point, with what we know, this is the best we could do in terms of writing this original expression here in a way that does not use negative exponents.
So in the negative next exponents here, you're wanting to get rid of them, period, regardless what, whether it's add, subtract, multiply, or whatever, or
Yep,
divide.
yep,
Its goal is to get rid of your negative exponents.
yep. And that'll be in the instructions in your homework. It'll be in big print at the top of the homework. And of course, you're not going to have any quite like this one right now. I'm just pointing out for later that when we eventually do see stuff like this, it's going to be tempting to somebody to try and say x squared plus y to the negative 3 over 5 is something like, I don't know, x squared over 5 plus y cubed, where it looks like they took the y to the negative 3, they moved it to the bottom of the fraction bar and changed the exponent, and didn't they just carry that operation of addition to the bottom with it? And just to be clear, if that plus was a multiplication symbol, then what I just wrote here would be correct. But if that's an addition, this is not correct. I mean, think about this one down here. This one right here. What is this? This is 2 cubed, which is 8, plus 2 to the negative 3, which is 1/8, divided by 5. Okay, what is 8 plus 1/8? It's 65 eighths. And 65 eighths divided by 5 is 65 eighths times 1 over 5, which is 65 over 40, which reduces to 13 over 8, or something like that. Okay, notice that is not the same thing as 2 cubed over 5 plus 2 cubed. That would be where somebody's trying to take this guy, move it to the bottom of the fraction bar, and change the 3 exponent, the negative 3 exponent, to a positive 3 exponent. And notice it looks like they just carried the plus from the top of the fraction to the bottom of the fraction. That definitely doesn't work, because the top would be 8 and the bottom would be 5 plus 8, and that would be 5/13. And that is totally different. So, general upshot here is this, and this would be a good summary just so you can capture what I've been saying here for the last 5 minutes. If I have, let's say, a times b to the negative n, that is definitely a over b to the n. Does everybody agree with that one? Since this is a product,
Yeah.
I can move this factor to the bottom of the fraction, and when I do, the sign of the exponent switches. So this one's okay. What I cannot do is take a plus b to the minus n and somehow flip that b to the minus n to the bottom and make a over b to the positive n. This is not right.
It would look more like A plus 1 over BN.
Yes, very good. So, okay, so David's saying, what could I actually write for this one? I could definitely say a plus 1 over b to the n. Yes, very good. That's correct.
See, if we could do our tests like this, I'd probably do a lot better. I'm serious. Talking it out, working it out, things like this, like a group session, or even with Miss Judy right in my ear, I can rock on. But when it comes to tests, I just blow up.
Well, this is where most of the serious learning happens, right? It's not on a test. It's when we're talking like this and when you're doing the homework. I would definitely say that this part of what we're doing has a lot more value than the tests do. Uh,
For me, it has been.
yep,
That's written proof all the way around.
yep, I agree. Okay, I'm going to stop now because now my heat's up to it's hovering around 81. I'll figure this out by Monday so I don't have to keep looking at that and worrying about it. Okay, so your test grades are loaded into the My Open Math gradebook. I will send you your tests, that is like PDFs of your actual tests that I scanned in. I'm taking pictures with a phone and then scanning them in PDF. I'll send those to you later today. I'll just send it through regular email. Like I said, I was going to try and put it in a Dropbox, but that didn't work out too well. Other than that, I'll put up your homework for this negative exponent stuff, and then Monday, let's see if you've got questions over either of these first two homeworks. Sound good?
That ought to do it.
Okay. Yep, you
I
too. Yeah, go
I'm
ahead, Bill.
sorry.
You're good.
I,
Go ahead.
I'm going to say I, I'm sending you an email. So when you get a minute, check your emails, please.
Okay, will do.
Thank you.
Sure thing. Have a good weekend, everybody.
Yes, sir. You too.